Hello and welcome to the Quiz 1 walkthrough. Just a reminder, if there's a problem that is 5-10 steps long and all you have written is the final answer, or just a reminder, that's not worth any points. Also, the test is done live during class time. I can't accept tests that are sent in hours and then one or two cases days later. They have to be completed and turned in by the end of class. All right, so walking through our quiz questions. The first one, we're reviewing solving a rational. So x plus x over x minus 5 is worth 5 over x minus 5 minus 7. So here, the only excluded value we're worried about, x can't be worth 5. Other than that, if it's in the set of reals, we get to keep it. So here our LCD is x minus 5, so we hit everyone with an x minus 5. So I took the liberty of already applying the distributive property on each side. So we have x squared minus 5x plus x is worth 5 minus 7x plus 35. This is quadratic, so we'll set it to 0. So x squared minus 4x is worth negative 7x plus 40. So x squared plus 3x minus 40 is 0. So x plus 8 by x minus 5 equals 0. So x is negative 8, or x is 5. Excluded value, x can't be 5. We only keep the 8. Second one, we're solving a quadratic. 2x squared plus 11x plus 3 is 0. Leading coefficient is not a 1. We had an odd in the middle, and in fact we would have a fraction in the middle if we got our leading coefficient to 1. Not factorable over the integers, so this one, quadratic formula, was the way to go. X equals, make sure you have two sides to an equation. Opposite of b, plus or minus square root of b squared minus 4 times a times c all over 2 times a. So that fraction bar should cover both parts of that. So an x is negative 11 plus or minus square root of 121 minus, let's see, 8 by 324 all over 4. So x is negative 11 plus or minus root 97 all over 4. And 97 didn't have any non-trivial perfect square factors, so that's as far as we went on that one. Let's see, our next one, we're multiplying complex numbers. So we have 5 plus 2i by 7 minus 3i by 1 plus i. So foiling out the first two, we have 35 minus 15 and plus 14 is minus 1i, and minus 6i squared. The 1 plus I doesn't get to just disappear. It is still attached there. Minus 6i squared is really a plus 6. So we have 41 minus I by 1 plus I. So now we have a plus bi times a plus bi again. So 41 plus 41i minus 1i minus I squared. So 41 minus I squared is worth 42, and 41i minus 1i is a plus 40i. Problem 4, the reciprocal of 9 minus 2i. For starters, 1 over 9 minus 2i, and then we rationalize. So 9 plus 2i over 9 plus 2i. So we're multiplying by 1, changing the look but not the value. So we have 9 plus 2i over 81 plus 18i minus 18i minus 4 times I squared. So upstairs we still have our 9, we still have our 2i. Downstairs we have 81, middle two terms drop, minus 4i squared is really a plus 4. So we have 9 85ths plus 2 85ths of I. So there's your a plus bi solution on 4. 5, we were asked to divide. So 2 plus 3i was divided by 6 minus 7i. Same idea, just rationalize like we did the last problem. So conjugate of 6 minus 7i is 6 plus 7i. And then we're just foiling top and bottom this time. So we have 12 plus 14i plus 18i plus 21i squared. So that's really a minus 21. We have a 36 plus 42i minus 42i minus 49 times I squared, so really a plus 49. So I have 12 minus 21, so negative 9. 14i and 18i would be 32i. And downstairs we have a 36 and a plus 49. So we have negative 9 85ths plus 32 85ths of I. No common factors on either of those. And to number 6. Let's find number 6. There we are. We're back to solving a quadratic. This time, though, we didn't land in the safety of the real numbers. We're out in the complex with b not equal to 0. This one was easier by completing the square since we had a leading coefficient of 1 and an even in the middle. So I moved the 29 over. Half of 10 is 5. 5 squared is 25. So left side is x minus 5 quantity squared. Right side is negative 4. Square root of both sides, plus or minus on the side with the constant. So x minus 5 is plus or minus 2i. So x is 5 plus or minus 2i. You can get there with the quadratic formula. It's quicker completing the square in that one. 7 was virtually identical to what we did in class. We just did a minus instead of a plus. So we're asked to show that z minus w quantity conjugate is z conjugate minus w conjugate. So by substitution, that's where we start. A plus bi minus c plus di. So a little regrouping, we have a minus c plus b minus d of I. Now we have the a plus bi format. We can do the conjugate. So that says keep each of these things and flip the sign in the middle. So a little regrouping, a minus bi. We have a minus c and a plus di. Pretty close to what we want, but we want w conjugate to be c minus di. So we'll go ahead and factor a negative 1 from those two guys, which will flip that guy. So I'll leave my a minus bi. And we'll factor a negative 1 there. So minus ac minus di. So if we distribute this, minus c times c is a minus c, minus times minus di is plus di. So z minus w conjugate, a minus bi is z conjugate, c minus di is w conjugate. 8, the distance between 2 points. We were given negative 5, 4 as one of the points. And the other point was 3, 9. So for that one, you just had to kind of sketch in your right triangle. So there's your distance. So from negative 5 to positive 3 is 8. From 4 to 9 is 5. So 5 squared plus 8 squared is distance squared. So distance squared is 25 plus 64. So d squared is worth 89, so our distance is root 89. 89 did not have any non-trivial perfect square factors, so that's as far as we went. 9, calculator problem. We just had one part to do on paper, and that is get the y by itself. So y was 2/5 of x squared minus 3x plus 1. So our y-intercept 0, 1. X-intercepts approximating from the calculator, they end up at about 0.350 and 7.150. So that was one of the ones where you're doing second and calculate, and you're looking for the 0. Uh, 10, we're then finding the algebraic, finding intercepts algebraically. So x-intercept happens only when y equals 0. So 0 is x squared plus 6x plus 7. Completing squares is the easier way to go on that guy. So we'll add 9 to both sides. So 2 is worth x plus 3 quantity squared. Square root of both sides, plus or minus on the side with the constant. So plus or minus root 2 is x plus 3. So x is negative 3 plus or minus root 2. And we just throw those guys into ordered pairs. Y-intercept's a little faster. 0 squared plus 6 by 0 plus 7, y equals 7, so 0, 7. We're looking at symmetry. So our original was y is x squared minus 6x to the 4th. So x-axis symmetry, flip something across the x-axis, and your y value will flip, your x value will be the same. So opposite of y is worth x squared minus 6x to the 4th. So y is opposite of x squared plus 6x to the 4th, not the same as the original. No on the x-axis symmetry. Y-axis symmetry, flip it across the y-axis, and it's your x that changes sign. Even number of negatives multiplied together, coefficient is positive. Odd number of negatives, 1 and 4 here, 5 total. That'll be a negative. That is the same as the original, so yes on the y-axis symmetry and origin symmetry, we flip them both. 1, 2. So opposite of y, opposite of x, quantity squared, minus 6 times opposite of x to the 4th. Do you need the parentheses when you sub? Yes, you do. Opposite of y, x squared minus 6x to the 4th, so y is opposite of x squared plus 6x to the 4th, not the same as the original. Uh, 12, approximating the zeros. 0 is x squared minus 9x minus 105. So there we temporarily let y equal x squared minus 9x minus 105. Calculate our approximation, and we are looking at the x values only. So here x was approximately negative 6 and 69/100ths. X was approximately 15 and 69/100ths. Let's see. 13, writing the equation of a line. We were given negative 7, 4 and negative 1, negative 11. Write the equation of a line, you need a point and a slope. So our slope m equals, so 4 minus negative 11 over negative 7 minus negative 1. So change in output divided by change in input. So our slope 15 over negative 6 Positive over negative is a negative, and they have a common factor there of 3. And then just change in y is your slope times your change in x. And you'll get the same answer out of either point. So I'll just use the first one, 4 and a negative 7. So y minus 4 is worth negative 5 halves of x. I have 1, 2, 3 negatives, so that'll stay negative, 35 halves. I'll add 4, which is the same as 8 halves. So y is negative 5 halves of x, and then that would be minus 27 halves. So that's one of the versions you could have left the answer in. You could have gone with function notation. F of x is negative 5 halves of x minus 27 halves. Or you could have gone with the standard form, clear the fraction, move the 5x over, and had 5x plus 2y is negative 27. Any of the three of those is fine. 14, we wanted perpendicular to y is 6x minus 2 and containing the point negative 1, 4. So the given slope was 6, perpendicular slope negative 1, 6. That way the product of the slope and its reciprocal is negative 1. After that, it's the same problem we did there. So change in y is the desired slope times change in x. So y minus 4 is negative 1, 6 of x minus 1, 6. And I'll add 4 in the form of 24, 6. So y is negative 1, 6 of x plus 23, 6, or the other two equivalent forms you can get for that. 15, just see your class notes. We had 2 proofs that we did. You just had to pick one of them and do it. 16, graphing. X minus 7 quantity squared plus y plus 8 quantity squared is worth 4. 4, recall, is 2 squared, so our center is at 7, negative 8, and our radius is 2. Okay, so center at 1, 2, 3, 4, 5, 6, 7, and negative 8. And then we're going 2 in each direction. So notice we had no intercepts on that guy. 17, standard form of a circle with the center at 5, negative 3, and with a radius of 4. So x minus 5 squared plus y plus 3 squared is worth r squared, 4 squared, or 16. Either one of these two on the right-hand side is fine. And we're already in standard form. 17, 18. Finding intercepts. X plus 2 quantity squared plus y minus 5 quantity squared is worth 25, or 5 squared. So radius of 5, and our y coordinate of the center is at a positive 5. So we should hit the x-axis only one time. We'll hit the y-axis twice, though, since we only moved to the left 2 and our radius is 5. So x-intercepts only happen when y is 0. So x plus 2 squared plus 0 minus 5 quantity squared is worth 25. X plus 2 quantity squared plus 25 is 25. So x plus 2 squared is 0. So x plus 2 is 0. X is negative 2. So negative 2 is 0. So there's the one x-intercept we expected. Y-intercept, we're expecting a pair of them. Again, because our x only went 2 to the left and our radius went 5 out. So 0 plus 2 quantity squared plus y minus 5 quantity squared is 25. So 4 plus y minus 5 quantity squared is 25. So y minus 5 quantity squared is 21. Square to both sides, plus or minus on the side with the constant. So y minus 5 is plus or minus root 21. So y is 5 plus or minus root 21, and turn those guys into ordered pairs. And last but not least, number 19, they start us with the general form and ask us to get a standard form and sketch it. So x squared plus y squared minus 4x plus 6y minus 12 is 0. So first we sort. And move that constant. So there's my x's, there's my y's. Constant, jot them to the other side. Okay, completing the square on the x's, I'll add 4 to both sides. Completing the square on the y's, I'll add 9 to both sides. So x minus 2 quantity squared plus y plus 3 quantity squared is worth, let's see, that'd be 16 and 9, 25, well, 5 squared. So we have our center at 2, negative 3, and a radius of 5, and I'll let you sketch that out for yourself. Okay, so that's our walkthrough on quiz number 1. Use that to help you study for the test in addition to your class notes and homework problems. Remember, as soon as the test is done, I do need you to send it in right away. I can't accept them if they're sent in a long time after the test has ended. All right, if you have questions, shoot me an email. Otherwise, I'll see you at the test. Thank you.